everyone, my name's Loz. Welcome to the Psych 1-2 lecture for ATAR notes this year. So today we'll be running through essentially just a bit of a recap or a preview almost of Unit 1. So I'll go over some of the stuff that you might have learnt already in this past term and some things you might be covering, in your next term in a couple of weeks' time. We will kind of be going through the content relatively quickly, but we'll be trying to cover it, as much as we can. There'll be a couple practice questions and obviously space for you guys to ask some questions as well. So yeah, essentially we'll just go through that lecture and you'll be able to access the slides and everything like that too. So you guys may be aware of how the ATAR Notes lectures run if you've been to some, perhaps earlier in the week or perhaps earlier in the year as well. Essentially ATAR Notes is sort of accompanied by students for students. So there are a lot of resources that can help you guys. I know, doing 1-2, you are most likely in year 11, potentially in year 10 as well. But in terms of like resources, especially for VCE, so, your 1-2 subjects and your 3-4s that you'll kind of go into, again, maybe this year or next year, you'll find a lot of helpful resources on the ATAR Notes page. So you can have a look if you are kind of interested in looking at some other things. So some of the stuff that I'm kind of referring to there, we've got obviously our lectures that you're here for now. Also things like your study notes, videos, depending on your learning style, may be more helpful for you. Kind of ATAR calculators as well, which may be a little bit more relevant next year. But yeah, a lot of things, even like the discussion boards, which are kind of helpful for you to talk with peers, but also recent graduates that can give you some advice too. So if you head to the website and essentially just register an account, you'll be able to access all of these. If you are looking for a little bit more help, there are some kind of other resources run by ATAR Notes. So TuteSmart is the tutoring company that ATAR Notes runs, so that I work for example. And so essentially it is online tutoring in both class settings and private settings as well. So the class settings, you'll get one class a week with your tutor and also some other peers in your class. And that'll be 90 minutes. You'll, go through content, do practice sacks, practice exams, things like that. If you are someone who prefers one-on-one, there is also private tutoring. So you'll have 60 minutes a week with just one tutor as well, depending on whatever subject you're interested in. If you're also looking for kind of study guides, ATAR Notes has got some study guides which essentially go over the content. There's also some topic tests that are obviously more, practice questions and answers and strategies for taking tests as well. If you are kind of into those things, obviously there's hard copy. There is also our kind of platform Ed Unlimited, which is basically a collection of all of the ATAR Notes publications, as well as some NEEP practice exams and things like that are available online. So it's almost like a Netflix subscription, but instead of movies, you're getting study guides. So yeah, that's what Ed Unlimited is for. You can use it on your laptop, your iPad, all of that kind of stuff. And you just will have access to all of the publications. So whatever subjects you're doing, you'll have access to all of them. So if you are interested in that, then again, you can feel free to take a little bit more of a look by heading to the website. Before we head into the lecture as well, we'd just like to give a special thanks to La Trobe University and RMIT, Deakin, UTS and Macquarie for sponsoring this series. If you guys are interested in La Trobe as well, feel free to take a look at their early entry program that they've got in the moment. I know you guys are probably in year 11, but yeah, feel free to take a look if it is something you might be interested in upcoming years as well. Okay, so today what we will be covering, essentially 3 kind of main sections. So we've got the essential 2 areas of study of Unit 1, so development and the brain. And then the third one is our scientific skills. So super, super important. It applies kind of across the year in Unit 1 and 2, but it's also the exact same skills that you're going to be taking into 3-4 next year. So that's why it's really, really important. I do always like to kind of stress to my students with the scientific skills, it's very easy to neglect them and kind of push them aside and not revise them because you don't see it as actual content. But it's really important because it's a lot of application. And, if you don't have that kind of awareness of terminology that we'll be covering, today in scientific skills, you can end up losing a lot of marks, especially in 3-4 when we're thinking of the exam. Sometimes research methods are sort of like notorious for being really tricky, but often it's just because they're not given the same attention as some of the other areas of study. So in units 1 and 2, it's a very kind of good time to be consolidating and honing in on those skills. So then you just apply them next year. Okay, so we'll head into development. So essentially, we're thinking of some kind of definitions here. We're looking at two main parts. So often you'll hear it as nature versus nurture in terms of what influences development. So you can see this dot point on the study design terms it as hereditary and environmental factors. So we're thinking here of hereditary things that are to do with genetics, and environmental, obviously things more so external to someone, basically. So the idea is that obviously your genetics do influence your development, in terms of physically and mentally as well. But it's also this other kind of debate almost, or not debate, but you can see like the versus aspect of it in terms of how your environment also influences you. So the people around you, the environment in which you grow up in, the events that happen in childhood, things like that as well. Those would be seen as, external to the person. They're not so related to hereditary factors or genetic factors. And the kind of debate aspect of this is the idea of which one influences it more. Is a child or a person kind of influenced more by their genetics or versus the environment? Before we get to that. So the, I guess, answer to that debate is essentially that they both influence each other, or they both can influence someone's development, essentially. So obviously your genetics play a really important factor in lots of different things, such as, for example, intelligence. It's seen that it is something that is determined largely by genetics, but it's also this idea that your environment has a big impact on your development as well. So in terms of caregivers, primary caregivers, parents, that sort of thing, experiences, obviously, if we're thinking about certain traumatic events that might happen, those can obviously shape a person's development quite a lot, just as much, if not more so, than certain genetics. So it's this idea that it's not really one or the other. It's not that it's all hereditary or that it's all environment, but that they both influence each other to varying degrees. And it's very much, rather one or the other, almost like a bit of a seesaw, that idea that both can contribute. In terms of the biopsychosocial model, this is really important. You go on to talk about this a little bit next year in 3-4 as well. So your biopsychosocial model, very intuitive in the name. It's about your biological, your psychological, and your social factors that influence both your development and also mental well-being. So next year in psych, you talk about it more so in the context of this idea of mental well-being or mental health. So it's very important to understand it in that context. But then also this idea of what I've just kind of mentioned in terms of psychological development. So with hereditary, you might be thinking more biological factors. Obviously, psychological can come into that as well. And then social factors kind of being perhaps a little bit more nurture aspect. So in terms of actually sort of defining these a little bit, biological are factors that originate or develop within the body. So obviously, again, genetics, brain chemistry, very physiological kind of things. Whereas psychological factors, you're thinking more so to do with the mind. So, personality, attitudes, values, that sort of thing, sort of cognition as well. And then lastly, social factors, everything kind of outside the body. So in the external environment. So you're thinking about, friends, family, relationships, schooling, again, sort of events that can happen, stresses, that sort of stuff as well. So the real thing that's kind of pushed with this, and do pay attention to this because it always comes up in practice questions, I think we probably have one in these slides, is this idea that all of these factors contribute equally. You'll often see it depicted as like a little Venn diagram. So you'll have, your little circle of biological, psychological, and social, and the idea that they all sort of have these segments that overlap. So it's this idea, again, almost this seesaw kind of thing. You see this a lot in psych, this idea of multiple aspects influencing, mental well-being or psychological development, and they're all of equal importance. So it's not that, biological doesn't influence psychological, which doesn't influence social, and it's not that, biological is 90%, psychological, is 5%, and social the other 5%. It's this idea that they all influence each other almost like together. They have influences on each other, but then also that they contribute equally to development and mental well-being. So really important to kind of understand this model and be able to apply it to questions with different scenarios as well. Okay, so in terms of the actual process of development, so you can see on the study design, it's kind of listed as emotional, cognitive, and social. So we separate these into these kind of models or theories as we see here. In terms of actual psychological development, I know I've been alluding to it a little bit the past couple of slides. We're just thinking about, obviously in the psychological context, how an individual develops from birth through to, adulthood or, being elderly. This idea of, again, what kind of influences the brain, how the brain actually changes, and how one develops. Obviously, if you think of an infant compared to an elderly person, extreme differences in the brain, right? So it's this idea of describing how this process actually occurs and what changes occur in the brain to sort of facilitate this. So you can see, again, it's this idea that you're constantly learning things, you're constantly experiencing things as you age, and this idea that these all contribute to your development, and kind of how we can describe these sort of changes. So with emotional, we'll have a look at all three of these as well. You think of Ainsworth and her kind of theories around attachment. Cognitive, we think of Piaget's sort of kind of steps of cognitive development, especially in childhood. And then Erickson is more our kind of psychosocial development from infancy right through to old age as well. So we'll take a look at three of these. So in terms of our attachment, we can see really it's described as the sort of bond that an infant has with a primary caregiver. So, often can be a parent, and how this bond actually really is important, especially in influencing not necessarily the course of the child's life, but their development, especially in infancy, obviously, but also how there are almost repercussions of this attachment that are evident later on in life, beyond what you can kind of consider as the attachment period. So you may have gone over this before, you may have watched videos of it in class, but Ainsworth, essentially this researcher who had these sort of experiments and we, described as this strange situation where an infant is kind of faced with different environments that obviously involve the primary caregiver, and the attachment formed between them is kind of observed. So again, you may be familiar with this, but you want to kind of think of behaviors that are demonstrated between the infant, when the primary caregiver is around, when they're not around, and what behaviors are shown, and that will kind of point to how the relationship is between the infant and the caregiver. So we think about this especially happening in infancy, as I mentioned, and how that will obviously affect the infant and their psychological development, and then how that in turn affects how that infant, once they've, grown older, how they interact with their environment and interact with other people as well. So these are some of our attachment things that we're kind of thinking about. Secure attachment is kind of our objective, what we would like to reach, because this one essentially shows the greatest sort of positive development, you could say. So with secure attachment, again, we describe it as being the one that's sort of good, but it's not that 99% have it, about 65 have it. So the majority, but kind of just. So it's kind of an even mix between the infant is dependent on their caregiver and they feel as though they can trust them, but they're also curious about the world. They also want to explore the world and they're happy to do so, if that makes sense. So again, we're thinking of this kind of seesaw analogy. You really want to have this mix of both in terms of curiosity about the world and not being almost reclusive, you could say, but this idea that they are still able to trust their caregiver and depend on them, but not too much. Some of the other types of attachment, there's insecure attachment. So this can kind of break into insecure avoidant attachment and insecure resistant attachment. So this is kind of seen when there's sort of less of an attachment between the infant and the caregiver, and it's characterized by almost odd behaviors by the infant. So with avoidant, we're thinking of, if you think about avoidant versus resistant, I know they're kind of similar, but avoidant is more so almost not recognizing or not really knowing the caregiver. So as you can see here, they treat them like a stranger. So, in the strange situation, it may be that when the caregiver returns or when the caregiver is in the room, the infant isn't really bothered by it. Perhaps they disregard the parent. They don't acknowledge them. Again, they don't show that dependence in them. Insecure resistant attachment is sort of an odd one. So when the caregiver leaves the room, the infant is unhappy. So again, showing a sign of connection between the caregiver, but then when the caregiver has returned, they're not almost happy to see them, if that makes sense. So it's almost a little bit contradictory, this idea of being unhappy when the caregiver is gone, but not being, satisfied or not being happy when the caregiver has returned. And it can be shown by some kind of odd behaviors in that sense, this idea of that resistance. Disorganized attachment is kind of the fourth one, and this was actually developed a little bit later. And this is one you might see more of, especially in year 12 when you talk about mental health. So it's, just very contradictory behaviors to the caregiver's presence. So at times they might be very, very attached, not wanting to leave. At times they might be very resistant, kind of almost, a combination between a resistant and avoidant, that idea of, wanting to leave, not being consoled, almost like frightened by the caregiver. Hence the term disorganized. And this is one that's relatively negative, and it can cause sort of like, I don't want to say issues, but kind of negative aspects of development that you can see in later life. So again, in year 12, you talk about how it might predispose these individuals to developing certain mental health disorders and things like that. So it's this idea that it often, although this is an infancy, when these infants, grow older, you can see certain traits that are expressed. They have sort of high levels of anxiety. It's this idea of not having this sort of trust in the world or in other people. So often their relationships can struggle a little bit. So there's that kind of impact that you see not only in infancy, but in later life. And this is why, you talk about it in this context of psychological development, like the study design dot point, this idea of how attachment, so a period in infancy, influences the brain at a young age and how that can kind of carry on throughout later life as well. Okay, hopefully that makes sense. Again, if you guys have any questions, pop them into the Q&A portal and we'll answer them. So going now, so that was emotional. We're kind of moving to cognitive now. So that was an emotional bond between infant and caregiver. The next two we look at are very much like they don't care about the caregiver, like it's just the infant, or the individual, I should say. So we'll look at Piaget. Again, we're thinking here of the cognitive aspect. So there's 4 stages. Again, it goes up to about 12. So we're thinking very much in childhood here. So you have your sensory motor, your pre-operational, concrete operational, formal operational. My advice with psych is always just break down the terminology and what they mean. Honestly, this might not be the best example of breaking it down, but like pre-operational, concrete operational, formal operational, pre versus formal, that idea that often in terminology, and you'll see this again in lots of the terms that you go over next year in Psych 3-4, you can almost guess what they mean. It might seem like a complex term, but then once you sort of break it down or once you read the actual definition of it, it makes sense as to why it's called that. I'm trying to think of examples off the top of my head. Maybe like when you do sort of stuff with stress, like you'll see things, coping, flexibility, emotion-based coping, things like that. I'm trying to think of other terms, but yeah, you know what I mean? It can seem like it seems like there's a lot of words basically and a lot of terminology, and you may try to kind of rote memorize it. And I really, really, really want to discourage you from doing that. And this can apply to all of your subjects as well. Try your best not to rote learn stuff. I mean, like in saying that, I'm sure rote learn a couple of things, but understanding and kind of deep understanding is the most helpful, and that'll help you, especially with short answer, because sometimes it's very evident in your short answer questions whether you rote learnt something and you're just kind of churning it out like a robot versus if you have an understanding of it, because psych is all about application, all about application. Like if you look at your, past VCAR exams, they're all scenarios. It's rarely, like what is the pre-operational stage of cognitive development? What is the formal? It'll be, so-and-so is a 4-year-old who's, describing blah, 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 blah. Describe what stage of Piaget's, stages of cognitive development they're in and why. So it's this idea of all this application, reading scenarios, drawing on your knowledge, and then being able to mesh them together almost. So when you have a deep understanding, an understanding of the content, that becomes so much easier rather than trying to like rote learn, definitions or rote learning these stages and trying to kind of almost like fit things into boxes. Okay, I hope that makes sense. Sorry for the little tangent, but hopefully you guys get what I mean. So looking at this now, so sensory motor, we've got our really tiny infants here. So in terms of our cognition, we're obviously thinking pretty basic. We're learning things here such as object permanence and goal-directed behavior. So goal-directed behavior, pretty self-explanatory, behaving with an aim in mind. I don't know, rather than just like aimlessly moving about. But object permanence is when babies or infants start to recognize that when things are not in your field of vision, they haven't actually disappeared from existence. They're still there. So often like, I remember my teacher used to always use the example of like, when you do like peekaboo with the baby and you like hide your face and they like love it. So because of this idea that the baby, like very young babies, they will think that you've actually disappeared. Or like, if you wave a little ball and then you put it behind your back and then they'll look like so lost and confused. It's this idea that they haven't gotten object permanence yet. This idea that if something is not in their field of vision, if they can't directly see it, it ceases to exist. So once you're going through the sensory motor stage, you begin to achieve this idea of object permanence, where you show the ball and you put the ball behind your back and the infant is aware that the ball has been moved. That just because they can't see the ball, it doesn't mean that the ball has just, disappeared and it doesn't exist any longer. It's just somewhere else. Hopefully that is kind of making sense. So when you move into pre-operational, you're kind of thinking of toddler age, I guess you could say here. So especially with thinking about cognition, lots of like interacting with other children or other people, especially here. Egocentrism is basically when they can only think about things from their point of view. So you'll often do, I remember my school did it as well, you'll do like an experiment with, often it'll be like maybe preps, I guess. You do like preps in year 2s and you can combine this with concrete operational as well. Like it's basically, showing you kids who are like 4, 5, 6-ish versus kids who are like 8, 9, 10-ish maybe, their differences. So you can see that in pre-operational versus concrete operational. So pre-operational kids, like the preps, they'll often, like you'll present them, I'm sure you guys may be familiar with this experiment as well. You present them with like a little setting. So there might be like a hill, like a teddy bear, like an animal or something, and I don't know, something else. So you'll be sitting like, say I'm where I am, you're where you are, you're facing them. And it'll be the idea that you'll say who is, or like, who's the hill closer to, or who's the teddy bear closer to, or something like that. And they won't be able to actually understand that what you are seeing is different to what they're seeing. So it's sort of ego, they only consider things from their point of view. They don't understand that, to them, the hill is closest to them and the bear is far away. So if you ask them, what do you think I'm seeing? They're going to say that, the hill will be close to you, the bear will be far away, because that's what they're seeing. So only when you, get a little bit older, do they realize that the hill is closest to me, the bear is further away. If you're on the other side, the bear is closest to you, the hill is furthest away. So that's the idea there. In terms of concrete operational, you see this idea of conservation. So lots of things to do with measurement. So again, you'll probably do this experiment with, if you go to a secondary school that also has a primary school, you'll probably be doing this. So you may get a really long tube, like a long and a tall tube and a fat and a short tube. And you may fill them with, let's say, 50 mils of water. So 50 mils of water in a long, thin tube, let's say that it looks pretty full. If you pour it into the fat and the short tube, it's not going to fill that high. It's going to look different. So kids that haven't kind of reached this concrete operational stage, this idea of the conservation of mass particularly, if you ask them which one has more water, and you show yourself, pouring the water in, i.e. that it's the same amount, the younger children will say the long one, because to them it looks fuller, therefore it must be fuller. So when you reach the concrete operational stage, you kind of get this idea that just because it looks different, you can see that it's 50 mils and you actually understand the logic of why something in a tall and a thin tube will look different in a short and a wide tube. So that's that idea there. Formal operational, I kind of just think of it as when they start to do math, complex math problems and stuff like that. So thinking about more abstract thinking kind of comes from symbolism, some more abstract symbolism as well, but also this idea of idealistic thinking, deductive reasoning. So they basically just get a little bit more mature and they're able to do some more complex abstract thinking and kind of logical thinking as well. So the last one we kind of look at is Erikson's psychosocial development. So again, this goes through basically from birth to death. So the idea is that each stage has a crisis. So this, again, this kind of versus thing. So trust versus mistrust, industry versus inferiority, so on. It's this idea that you have this crisis, almost like a little dilemma, and you have to choose between one or the other. And depending on their psychosocial development, so again, we're thinking lots of things in the external environment as well, that'll influence which one you choose. I guess, yeah, you could say choose or kind of achieve. And the idea with this is that you are meant to be achieving one. So trust versus mistrust, you're obviously wanting to go with trust. Initiative versus guilt, obviously wanting to go with initiative. Intimacy versus isolation, you're obviously wanting to go with intimacy. So the idea is that if you lean towards the other one, such as guilt or isolation or despair, you have to kind of resolve this issue before going to the next one. So obviously this has a lot of cons as well. It is quite an old theory. It's been edited, it's been, upgraded, updated, all that kind of stuff. In terms of kind of fitting it more logically, but you just take a look at, Erikson's kind of original theory and what he sort of thought about how you go from one stage to the next. And this idea of almost getting stuck on a stage. So I won't talk through them too much in detail. We'll kind of move through them because obviously we have a bit of stuff to get through. But trust versus mistrust, again, as an infant, we're thinking about, trust again in caregivers, trust in the outside world. Initiative versus guilt, this idea of initiating often actions like play. So if a child, for example, they ask their parent, do you want to play, dress ups with me, or some other kind of fun, role play with me, blah, 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 blah. And then the parent might respond, yes, that's so fun, let's do it. And then you have a really fun time, whatever. That idea that it pushes them to be more, to take more initiative and to take, any ideas they have and to not run with it, but, they have the confidence to initiate that. Versus guilt might be, if friends or, family members, their other peers might be no, I don't have time for this, or stop bothering me, things like that. They start to feel guilty. They feel as though, oh, this idea that I've had is silly, it's bad, it hasn't led to a good outcome. So there's that example. You can think in the older years, integrity versus despair, generativity versus stagnation, kind of productivity. So what you've done with your life, is it good? Is it bad? Generativity versus stagnation, are you going somewhere? Have you achieved these kind of things? Stuff like that. Okay, so moving on now to critical and sensitive periods. In terms of psychological development, it's this idea of achieving things that you learn or kind of actions or behaviors, um, and whether they need to happen in a certain time. So again, very intuitive based on the name. Critical periods, it's critical. If you do not achieve this ability or this action, this development in this period of time, you will never achieve it. Whereas sensitive, again, as the name suggests, sensitive, in this period, your brain is extra sensitive to developing this ability. So it'll be easier, it'll be faster. So after this period, it's going to be harder to gain this ability, but not impossible. Whereas critical periods, it'll be impossible. So in animals, you can think of imprinting. So, in infancy, this idea of, the caregiver, imprinting, with animals, I don't know. I always think of like ducks. I think in my textbook, I talked about ducks. I don't know if it was ducks, but there's also, I remember my textbook as well, I think like bats, they did an experiment on bats with their vision. So when they were born, they like covered the bat's eyes. I think this applies to other animals as well, maybe even humans, covered their vision immediately after birth and then removed it after, I don't know, I guess a couple hours or a couple of days. Like they, obviously opened their eyes. But the bat or the other animal, whatever it was not able to see, was blind for the rest of their life because they didn't gain this ability to see or, for vision in this critical period. So even though, let's say, I'm making up the numbers here, but let's say it was like 2 hours, it's such a short time frame, right? And, you then open their eyes for another 4 years, but because it didn't happen in this specific period, doesn't matter how long, it'll be open for, they're not going to develop that vision. So that's a critical period. Whereas a sensitive period, so for example, learning a second language, I think it's before kids are like 11 or 12, their brain, you often hear people be like, oh, their brains are like sponges, because they like literally are, like they have a much greater aptitude for learning a language when you're within that age. So yeah, I think it's like 12 or younger. But then obviously if you're older, you're still able to learn a language. It just takes a little bit longer. Your brain doesn't have that sponginess to it. But it's not that you're never going to be able to learn another language. Okay, so moving on here, you can see the study design dot point is a little bit longer. And I think while I'm on this idea of study design dot points, get into the habit of using the study design. Rely on study design. Memorize the study design, not memorize it word for word, but know what dot points are covered on the study design. It helps you a lot in your short answer. It'll help you a lot next year in your 10 marker, or if your schools do 10 markers this year. And it can also guide your study really well. So I would recommend like using study design dot points, just like we're doing here. Like you can write them on top of your page and then write your notes from that, just so you know that you're on the right track. Because sometimes it's easy to kind of get off track with like lots of stuff in the textbook or in videos or in other resources you're using. So it's important to have the study design and be aware that you know that you're on track, you know that this is what's going to be covered in your tests, and you're not spending time learning stuff that's irrelevant. Okay, so looking at our study design dot point here, the usefulness and limitations of criteria to categorize behavior as typical or atypical. So it's this idea of, obviously everybody's different, very, 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 very different, which I'm sure you guys are aware of. And so you broadly can categorize behavior as typical or atypical. And so Vika, I want you to be aware of in what circumstances or in what ways is having criteria that almost like, again, puts people into boxes. Why is that helpful at certain points? But then also what are its limitations? So sometimes if we think of limitations, pretty obvious, as I mentioned, everybody is different. Everybody is shaped by their experiences. We've just talked about all these things that influence, psychological development. You got your emotional aspect, your cognitive aspect, your social aspect, your nature versus your nurture. Obviously, people are all going to be a little bit different. So when you categorize something as, typical or this is atypical behavior, And obviously, if someone's demonstrating atypical behavior, it's something that you want to, figure out, why is their behavior atypical? Why is it different to what they usually do? And is this a sign of something going on, you know, that might not be what you want it, oh my gosh, I can't even speak, might not be what you want to be happening? Or is it a sign of, neurological decline? Or is it just that, they've had a certain experience and they're acting a bit different? So that's why, it can be useful in sort of figuring out, does this individual need help? Has something gone on? Is there a reason why they're acting a bit different? But in terms of limitations, it can be, again, this idea of categorization, basically. It's almost like trying to, I don't know if you guys might be aware of like continuous and discrete data. So discrete data is like things that can be 1, 2, 3, or 4 almost. So it's like, children, how many children do you have? You've got 1 child, you've got 2 children, you've got 3 children. You can't have 1.5 children, 1.75, 1.8333 children. That's that idea of it being discrete. Whereas continuous, like height, it can be however many millimeters. So it's almost, to draw the analogy, it's almost like this idea of trying to force this continuous data to be discrete or to be categorical. So that's where those limitations can kind of come in. And obviously it's very tricky to describe something as normal, again, because of this idea that what's normal to some people may not be normal to others. So when we talk about being mentally healthy and having a mental disorder, we'll look at kind of the mental health continuum, and you look at that a lot next year as well. But again, it's this idea of what is this individual usually functioning like, and is it different, and how different is it? And then the big question, why is it different? So that's what you kind of think about there. Often with normality or, atypical and typical, it's less this idea of what do I think is normal? Is this person normal? But more so, what is this person usually like? Are they different from their usual self? Okay, so in terms of atypical behavior, again, very, very hard to describe it. So we do our best. You guys may be familiar with the DSM-5, very useful in psychology, kind of just describes mental disorders and things like that. So we'll have a look at the things that are listed kind of here. So violating social norms, this idea of, and again, this is not just your like not conforming to society. Obviously, that's very different. This idea of extreme kind of diversions or extreme, antisocial behavior. This idea of having atypical behaviors that actually are arising from a, condition, a diagnosable condition, personal distress. So this idea of how is it affecting their functioning, their daily life? Is it evident that this is causing this person distress and that they're struggling with it? Maladaptive behavior, again, sort of with this daily functioning. Is this behavior, just sort of different, or is it actually harmful? And then also cultural perspective. So as I've talked about, between individuals, it can be different as to what, what I perceive as normal may be different from what you perceive as normal, but then also cultural values. So, what one culture perceives as normal or not normal or atypical may be typical in a different culture or atypical. So it's very, very important to take all of these things into account. And that's why it can be very tricky to label behavior as atypical or typical. Okay, so then we look at normal variations of brain development within society. And we talk about this idea of neurodiversity. So again, we've talked about, psychological development, and specifically here we're looking at development of the brain and things, that might affect cognition in particular, and this idea of normal variations. So again, as I've discussed, it's this idea of everybody being different. There's no one way a brain is meant to develop. There's no one track or one timeline that a brain should develop in. And again, as I've said before, you think about genetics, you think about nurture, you think about your emotional, your social, etc., etc. All of these different things that influence the brain, your biopsychosocial model. There's so many things, so many different aspects that influences an individual's mental well-being, influences a person's psychological development, and even outside of that, physical development, things like that, and obviously how that interacts as well. So everybody kind of moves on a different timeline or on a different path in general. And that's what we see with these normal variations and this idea of neurodiversity. So as it suggests, this diversity, so this kind of difference. And again, if you think of like genetic diversity in a biological aspect, it's not this idea that it's, atypical or, the wrong kind of pattern of developing. It's just this idea that it's different. And again, it's just variations of development. So what we see here, different ways people experience and interact with their environment, and obviously this idea of learning, memory, cognition, all those sorts of things. And again, that everybody kind of behaves, learns, or thinks in different ways. You can imagine if everyone was to perform an action in the exact same way, if everybody was to learn in the exact same way, we'd all be robots, really. So some of the kind of neurodiverse conditions that you might talk about in class, obviously it depends. With Psych 1-2, there's a lot of leeway. Your schools can teach a lot of different things, but some of the typical ones you may see are ASD and ADHD. So with ASD, again, this idea of a spectrum, and we'll talk about, mental health being on a continuum as well. It's very similar, this idea of being on a spectrum. So it's even this diversity within the condition itself, about how some people may experience these variations, to differing extents. So we're seeing things like communication, behavior, learning, some of these variations that affect these sort of processes to do with brain development, psychological development. And again, because it's on a spectrum, this idea that, people with ASD won't be experiencing these variations similarly, to the same extent, in the same way. ADHD as well, we're thinking about this difficulty in completing tasks or performing tasks and routine. So that's, a behavior thing as well, where we, might think about others, doing more with cognition and things like that. ADHD we think of a lot with behavior and things like that as well. So again, there may be other conditions that you kind of look at in class. But yeah, there's a lot of examples when we discuss neurodiversity. Okay, so moving on now, again, a bit of a chunky study design dot point. So looking at the role of mental health workers, psychologists, psychiatrists, and organizations, so pretty multifaceted thing here, in supporting psychological development and mental well-being, along with the diagnosis and management of atypical behavior, including what we're discussing here, culturally responsive practices. So in terms of the other aspects of the dot point, it's just this idea of, again, a multidisciplinary team. So you've got mental health workers, how they might differ from psychologists, how they might differ from psychiatrists, and actually organizations, so, support networks, that sort of thing, in terms of supporting this development and mental well-being. So when we're looking at culturally responsive practices, we have a few aspects of this here. So individual experiences, again, understanding, I feel like I'm harping on about the same thing here, but understanding that everybody's experienced different things in their lives and how this reflects in their development and in their behavior as well. Hiring diverse staff, so this idea of feeling kind of related to, seeing similar people, interacting in this idea of a comfortable environment is really important. Being involved in the community they work for as well. So, these psychologists, these psychiatrists, working in the, being involved and interacting in the community that they work for. Again, kind of links to that diverse staff aspect, just creates this familiar and comfortable environment. And I'm sure as you guys can imagine, if you're thinking of stuff to do with mental well-being, that's a really important aspect. And then lastly, listening carefully to patients' experiences. Again, almost tying in with the first dot point there, understanding, what patients have been through and this idea of past experiences and how that influences them as well. Okay, so this is a continuum, is what you're meant to be looking at down the bottom there. So this is the idea of how you have this continuum that everybody sits on in terms of mental health. So again, you'll talk about this. Basically, mental health is an area of study next year in Psych 3-4. So you'll look at this sort of continuum in a bit more detail. But it's this idea that you have mentally healthy towards one end, mental health problem sort of in the middle, and then mental health disorder. So it's super important to understand that we're looking at a continuum. You're not looking, again, at boxes. In psych, it's all about fluidity and not boxing things in, right? So it's this idea that, mentally healthy, we're thinking right down the continuum here. Sure, someone may be mentally healthy in that way, ticking all the boxes, but, you may be a little bit down here, but you're still mentally healthy. Maybe you're having a bit of a bad day. Maybe you're having, a lot of stresses recently, but you can still kind of fit in that mentally healthy, category. But it's just this idea of where you're sitting on the continuum. You then get sort of to the middle, which is your mental health problem. Again, where you understand it's a little bit more transient, but, you really may be facing a bit of an issue. This stressor may be really putting pressure on you. Hopefully you guys don't get very stressed about, psych or 1-2 or your exams or anything like that. But, if you have this sort of prolonged stress that's kind of causing you to feel that way, then you may be slipping into the mental health problem territory there. And then obviously, let's say that this stress is really prolonged. It's affecting you in a lot of different ways, affecting your functioning. You stop going to school, you struggle with your relationships. That's when you might be slipping a bit further down the continuum in towards the sort of mental health disorder region there. And then again, it's this idea that you can move up and down. And so it's that if you are mentally healthy, you may not be, super, super, super on top of everything. And if you've got a mental health problem, you may not, have a diagnosable mental health disorder. This idea that it's all kind of differing on that continuum. But you can see a good definition of this here. Again, very relevant next year. But we're thinking about coping with the demands of life, being able to work productively, being able to manage, your daily tasks, contribute to society, interact with people as well. That's what we kind of class. So it's a very, again, kind of multifaceted thing. Okay, so that is essentially the stuff on development. We'll have a little look at these practice questions. So the key assumption, we'll kind of walk through them together, but have a think about it as we discuss them. So the key assumption underlying the biopsychosocial framework is that psychologists alone cannot diagnose mental illness. So again, whether that's true or not, I don't want to talk about, strategy and stuff too much, but even if you can't rule something out as 100% incorrect, it doesn't mean that it's going to be the right answer. So like psychologists alone cannot diagnose mental illness. You don't really know about it. I mean, the answer is no, but as in like psychologists alone can diagnose mental illness. But it's this idea that what the biopsychosocial framework is. And so even if this is true, like let's say like, oh yeah, it's true, it's not the key assumption. So it doesn't even matter if like, oh, is this true? Is it not? Like, what do I know about diagnosing mental illness? It's this idea that the biopsychosocial framework, this isn't really part of that. B, factors from several domains may combine to influence mental health. Yep, sounding pretty good. Social factors are more important than psychological factors. Not true. Remember we talked about how they influence each other equally. So for the same reason, D is incorrect. Okay. In humans and animals, the timing of an experience can significantly influence the learning that takes place. Explain how a sensitive period in brain development differs from a critical period. Give an example of each. So you can see this is 3 marks. So it may be that I would probably say it's 2 marks for explaining how a sensitive period in brain development differs from a critical period. And then 1 mark for an example, probably. Maybe the other way around, but that's what I would kind of put it as. So in terms of your sensitive period, it's explain how they differ. So a really, really important point here, and remember this for your psychs and for exams, if it asks for a difference or how something differs, you have to clearly draw a comparison between them. You can't just be like, sensitive period is this, critical period is this. It's asking you to explain how it differs. So a sensitive period is this, whereas a critical period is this, highlighting the similarities and the differences. So you would talk about how critical period and a sensitive period, they both involve this idea of an ability being perhaps optimized in this certain time. But a critical period is obviously a little bit more vital for this kind of learning or this ability to form, as if it doesn't form within the critical period, it won't happen at all. The individual is unable to ever form that ability. Whereas a sensitive period, basically it's easier to form that ability, but it's not vital. So they can still develop this ability later past the sensitive period. It'll just be a little bit harder. It'll just take a little bit longer. So your examples, the ones in our slide, we're talking about imprinting and learning a language. There's obviously a couple of other ones as well. Okay, so we'll move on now to kind of the second part of your area of study. So looking at the brain. So it depends how your schools have kind of been running things, I guess. And yeah, with 1 and 2, there's a lot more freedom. So in year 11, schools can choose like a decent amount of what they want to do, whereas 3, 4 is a little bit more rigid. But if they are following the study design pretty strictly, your school may have done development kind of in term 1. You may have already started stuff on the brain, or maybe going into it in term 2, but I'm assuming most schools would have probably started stuff on the brain already. So we're looking at our study design dot point here, different approaches over time in understanding the role of the brain. So different approaches over time, we're looking at some of these old approaches that may have seemed really good at the time, but now that we know a bit more about the brain, it's a little bit, interesting. So the heart hypothesis and the brain hypothesis, it was this sort of debate, I suppose. Oh, this should be saying in the brain. But this sort of debate saying, is the heart the center of thinking, or is the brain the center of thinking? And then that kind of leads to the mind-body thing. So this idea of, are our brains and our mind the same thing? Is our body connected to our mind? Are they two separate entities? Stuff like that. And remember, this is, quite a couple years back, couple centuries back even. So a lot was not known. Just like right now, a lot of the brain still isn't known, but back then even less was known. So it's kind of a valid question to ask. Now we know this idea of obviously mental processes being in the brain and things like that. But yeah, it was this idea of, how does the brain interact with the body? Does the body influence the brain? Is the mind in the brain? Is the mind in the body? Is the, mind or is thinking in the heart versus in the brain? Yeah, so a lot of these questions in terms of kind of understanding what the actual point or the actual function of the brain was. And then phrenology, this is a little bit of a pseudoscience as well. So this idea that the physical characteristics of the skull shows you what someone's personality is like. So if you have a little bump here, or your head is flat here, then, you're a more aggressive person, or you're a more intelligent person, or you're a more relaxed person, stuff like that. So obviously that has been kind of disproved, or this idea that, the bumps in your skull don't really dictate your personality. In terms of actually figuring out how, so figuring out what the brain actually does, there were these certain techniques. So ablation, this is a little bit more of an old school one, as you can imagine. So parts of the brain are basically just taken out or destroyed, and then they figured out like, okay, what function is lost? So I guess pretty clear method of testing, obviously pretty unethical. Electric stimulation is obviously a more modern thing as technology grew. But this idea of, when you stimulate the nerves in this part of the brain, what happens? How does it affect this person functioning? Does their arm move? Do they stop talking? Do they, blink, stuff like that? And then that's how a lot of the kind of understanding of what regions of the brain control, what parts of the body or what functions, how those are kind of found out. And kind of, again, further findings from that is this idea that the brain, obviously we're going to talk about, structures of the brain and, main activities that happen in each part of the brain. But again, as you probably know what I'm going to say, we don't like box things into categories. The brain is just a big mix of everything. this idea of it being holistic. So, this part of the brain is more in control with this certain function, and this part of the brain is more in control of this certain function, but they can both have it's like having your fingers in all the pies, I don't know, whatever the saying is. All parts of the brain can contribute to all different functions. And as we'll learn about as well, when certain parts of the brain are damaged, other parts of the brain can take over for that, damaged region as well. Okay, so split brain experiments. These were done in the setting of epilepsy. So they figured out cutting the corpus callosum. So you have your left hemisphere and your right hemisphere. The corpus callosum basically connected. So it's like your little highway, your little bridge between the two hemispheres. And people with severe epilepsy, what they kind of figured out is like, if we cut this, it stops that communication. So then they're less likely to get seizures. But then they also found out like, when we cut this corpus callosum, look at all these kind of effects of what happens when the left hemisphere and right hemisphere can't communicate. So this idea of not being able to talk basically between your right and the left. So the left hemisphere is very responsible for this idea of speech, for talking. So if you have, it's going to be a little confusing. I know you guys will hopefully be aware of the fact that the right side of the body is controlled by the left side of the brain. So if you have things in the left visual field, they're processed in the right hemisphere of the brain. And you won't be able to name these because of the idea that you can't extract information from the left side. I hope that makes sense. So let's say, I've got an apple in my left visual field. So it's on the left side of my face. Yeah. So the right hemisphere will kind of process that. So that information will come through and it'll be processing that in the right hemisphere. So the left part of your brain knows that this is an apple or describes it as an apple. So the right hemisphere is saying, okay, I recognize this object. What's it called again? But it is unable to take that information from the left side to the right side. So that's why it can't be named. On the other hand, if you've got something presented in the right visual field, you process that in the left hemisphere. And because the left hemisphere has the names for stuff, you're able to name it. So you're able to say, oh yes, it's an apple. Because the knowledge that this thing that I'm seeing is an apple and actually being able to say that it is an apple, that's in the left side of the brain. So anything that's processed by the right side of the brain, i.e. the stuff on the left side, I know it's complex, that's what you won't be able to name. Because again, that road is cut off. The right side of the brain is by itself. The left side of the brain is by itself. They can't, any functions that are kind of exclusive or mainly on one side or the other, they can't be shared anymore because of this idea of the band of nerves being gone. Okay, so talking about this idea of nerves, this and that, neurotransmission is important to understand this. I will say in the new study design, so for this year, the kind of important, I guess, parts of a neuron and the actual synaptic stuff that's been sort of de-emphasized or emphasized less. But I think it's important in being able to understand what we actually talk about in terms of neurons and synapses and that sort of thing. So I do just want to flag, it is probably not like the highest yield stuff, but I think it's still important for actual understanding. So here is what we call your presynaptic neuron. So this is the synapse. The synapse is the gap between the two neurons. So again, very intuitive in the names. Presynaptic neuron, the neuron before the synapse. Postsynaptic neuron, the neuron after the synapse. So the synapse is interacting between what we call the axon terminals, or the terminal buttons, and the dendrites of the next neuron. So I like to think of it as like the toes and the hair. I know that might sound a little bit strange, but you think about the impulse or the communication going from the top to the bottom. So essentially the dendrites, and it passes through the soma, passes through the axon, through to the axon terminals, which is what we see happening on this side. So to me, what I like to think of it as is like the dendrites are like the hair, the soma, almost like the head, because it's like the cell body, it does all the complex stuff. The axon is the body, and then your little terminals, these kind of look like toes or feet, maybe. So that's how I like to think of it. So it goes from top to toe, top to toe, top to toe. And so you have, 300, let's say, neurons lined up one after the other, top to toe, top to toe, top to toe, top to toe. The information is just shooting from one neuron to the next neuron to the next neuron to the next neuron through these little synapses. That's how it's going from one neuron to the next. So to cut a long story short, you have your little neurotransmitters in here. They're basically released across this gap, and they bind to receptors on the postsynaptic neuron. They do their little thing, and that sends the impulse through this neuron to the next one. That's the simple gist of it, really. So when you form new neural pathways, you're forming new synapses, new connections between different neurons, and obviously kind of all the physiological stuff that goes on in terms of number of neurotransmitters, number of receptors, all that kind of stuff. But yeah, that's sort of the basics of it. So I think understanding that can help you a little bit in your knowledge when it comes to stuff like synaptic pruning and rerouting, that sort of stuff. Okay, in terms of the actual structures of the brain, you're looking at hindbrain, midbrain, forebrain, and the cerebral cortex. So here we have our hypothalamus and our thalamus and our cerebrum. So these are in our forebrains. You can kind of see these in here. Don't worry too much about, the fissure or anything like that. Here's the corpus callosum, sort of for context. Again, it's just that line. So we look at our hypothalamus and our thalamus, very much to do with sort of regulation. You're thinking about hormones, you're thinking about homeostasis, stuff from, your visceral, your sensory organs. Lots of this kind of filtering of information, regulation, that sort of stuff. Cerebrum we'll look at in a second. Midbrain, you're kind of thinking of your pretty important function. So your reticular formation, stuff to do with consciousness, arousal, that sort of stuff. And then hindbrain. So your medulla is super important, connects your spinal cord to your brain. So if your medulla is injured, it's like really key function. So things like breathing, again, sort of consciousness, this idea of actually connecting the spinal cord, so that sort of highway of neurons, and ultimately the rest of the body through to the brain. The cerebellum you think of with stuff like balance and like coordination. Okay, so this is our cerebral cortex, or our cerebrum. It's basically the outer layer of this brain. And so it's separated into your frontal, your parietal, your temporal, and your occipital. So frontal lobe, as the name suggests, at the front. So here's what we think about when we think of like complex, like actual thinking. So when you think about like what does the brain do, like the really basic instinctive stuff you think, that sort of happens in the frontal lobe. So like, I don't know, doing your maths and like reading and stuff like that. Your problem solving, your abstract thinking, all those kind of things. Your primary motor cortex, it's basically like, I'll try and draw it. It's like a little band that sits along here, kind of. And as the name suggests, very involved with your kind of motor stuff. So motor movement, voluntary movement, that sort of stuff. Your parietal lobe, so your somatosensory cortex basically is like touching the primary motor cortex, and it sits here. So at the front, essentially, of the parietal lobe, and that's involved with a lot of sensory stuff. So kind of sensing, information like touch or heat, things like that to do with sensory stuff. So somato in terms of the body and sensory. Occipital lobe, basically to do with eyes. So everything with vision, as the name suggests again. Temporal lobe, so kind of sits on the side, to do with memory, but also particularly to do with hearing. So you've got your primary auditory cortex. So you can see, again, motor cortex, somatosensory cortex, visual cortex, auditory cortex. They tell you what the lobes kind of do. So yeah, we think about to do with hearing. Also involved with memory, as I mentioned, you've got some important structures in there to do with memory and stuff with like facial recognition as well. Okay, so these are two super important areas to be aware of. So we've got Wernicke's area and Broca's area in the left hemisphere. So remember we talked about that corpus callosum and how the left hemisphere is important for speech and language. So Wernicke's area is in the temporal lobe, so here, and Broca's area is in the frontal lobe. Remember that. Something you also have to remember is what they actually do. So Wernicke's area, the way I like to remember it, is temporal lobe is with auditory. So Wernicke's area is to do with actual comprehension. So understanding what words mean. Whereas Broca's area is to do with speech production. So you can kind of think about like, the motor cortex, actually like maybe moving the mouth, moving the muscles and stuff like that. That can kind of help you distinguish between what they do. So if you have a question and it's like, this individual is struggling to understand language. So what that means is you've got a damaged Wernicke's area. They will be able to speak very clearly. Their enunciation will be fine, but it will be completely jumbled. So it'll be like, cat, spanner, computer, wall, light bulb, right? So it doesn't make sense, but the actual production of the speech is fine. It's clear. Whereas if you have damage to Broca's area, they will be able to fully comprehend what you're saying and kind of formulate that sentence, but they won't be able to actually speak it. So it'll just be complete gibberish in terms of what they're saying. So you can see how these two areas are really, really important in terms of actual speech and language. Okay, so we now look at the idea of how the brain changes and how, when we experience things, when we learn things, how that actually changes the brain physiologically. So we look at these three kind of processes: myelination, synaptogenesis, and synaptic pruning. So myelination, you might be familiar with the concept of myelin that happens sort of on the outside of your axons, and it's very important for sort of insulation. So just like an electrical cord, that's got its little insular tube. It's the same thing for a neuron. It just helps increase the efficiency of the electrical impulse, and it prevents sort of interference from other neurons as well. Synaptogenesis, again, as the name suggests, I feel like I'm saying that a lot, as the name suggests, this kind of creation of new synapses. So that occurs really rapidly after birth. So when you are a baby, like babies' heads are huge in proportion to their body. Their brain's just growing like crazy. So you have a lot of these new synapses, these new connections that are forming, as the baby like learns a lot of stuff as well. Synaptic pruning. So this is important. This happens again kind of after this period of synaptogenesis, when the brain realizes, okay, I've made all these lovely pathways, all these lovely new synapses, all these connections. I'm not using them. I'm going to get rid of them. Again, just focusing on, efficiency and keeping resources that the brain needs. So if the brain has a pathway and the brain realizes, I haven't used this pathway in a long time, I'm going to eliminate it. I'm going to get rid of this because it's unnecessary. So that's that idea there. Super important concept to understand now is this thing of plasticity. So when we think about, synaptic plasticity, neural plasticity, it's this idea of being plastic, really. So being flexible, changing over time. So as you experience things, as you learn things in particular. So again, this is something you'll go over next year in 3-4 to do with learning and memory, how the brain and like at a synaptic level, how it actually changes as you learn information. So adaptive plasticity, this means, again, as the name suggests, adaptive. You're adapting for something. So you're compensating. So if you have a certain region of the brain that perhaps is damaged, the brain adapts and kind of other areas of the brain essentially overtake or take on that role. So that function basically isn't lost. So if you've got a huge chunk of the brain, let's say a huge chunk of the right side of the brain, so maybe a lot of your left-sided, limb functions are lost. If you're a pretty young person, the body may be able to actually adapt. So a lot of, rehab and physical therapy, you may gain that function back. compared to an older person whose brain is basically less plastic. They have this, they have a lower ability for the neurons to be able to actually be as adaptive. And that kind of links to this concept of developmental plasticity, where we're kind of seeing that, in a baby, this development where we've got stuff like synaptogenesis. So this kind of creation of new pathways rather than trying to get established pathways to take over functions. Okay, so we have these two important processes, so rerouting and sprouting. It's in the name. So rerouting, we're just thinking of when you have a healthy neuron and perhaps another connection has been damaged or another pathway has been damaged, the neuron will just take another path. So it's basically like, if you've got a path, it's blocked, road closed, you've got roadworks, you just take another path, you reroute that. Sprouting is when you've got this neuron and it basically just sprouts like a little plant. It just grows these extra networks, so extra dendrites. Remember, that's where your receptors are. And so that means it can just connect and hold hands with a lot more neurons. So now you've got a lot more connections in that way. So again, that's kind of what we've talked about before. So this idea of rerouting and sprouting, it allows the brain to, again, adapt and just take over and replace lost connections. Okay, so if we're thinking about brain injury, again, this is a very broad dot point. So you're thinking about how somebody's brain is damaged based on, or how a person's functioning is affected based on damage. So again, your biopsychosocial kind of approach. So you can see there's a long list here. There's a lot of other ones that are involved as well. It just depends. It really, really depends where that brain damage is, the extent of the brain damage, how old the brain damage is, really, all that kind of stuff. So you can see a lot of things: reduced motor activity, reduced planning, personality changes. Again, think about your lobes. Think about if a brain injury was in your occipital lobe versus your frontal lobe, what the kind of damage might be there. Okay, again, sort of like a bit of a wishy-washy dot point. The contribution of contemporary research to the understanding of neurological disorders. So the example one that we'll talk about in this lecture is Parkinson's disease, but you can imagine there's a lot of other neurological disorders, Alzheimer's, for example. And what the point of this study design dot point is to have you be aware of how contemporary, so modern research, recent research, allows us to understand this sort of stuff. Because again, be mindful, a lot of the brain is unknown. Like even right now, a lot of the brain is known, but there's still so much that is unknown, and it can be very hard. It's a hard thing to kind of figure out what the brain is doing. So that's why it's this idea of kind of modern and recent research, how that's kind of helped us in terms of, diagnosing and understanding things like Parkinson's, things like Alzheimer's, other forms of dementia as well. So with Parkinson's, the basic idea is that you have neurodegeneration. So you have neurons in this area called the substantia nigra, and they basically just die. These neurons are responsible for producing a certain hormone or a certain neurotransmitter called dopamine. So logically, these neurons are dying. These neurons are meant to be producing dopamine. You're going to get low dopamine. And dopamine is important in your primary motor cortex, so what we talked about here, in terms of your initiating and controlling voluntary movements. So if you've got that impaired communication there, you're going to get impaired control of those movements. So that's why you often see with Parkinson's, a big symptom is tremor. This idea of controlling these voluntary movements is affected. So then you see that tremor, and you see, other things, perhaps to do with gait or posture as well. Lots of things to do with that impaired control of those voluntary or, skeletal muscle movements. So in terms of some contemporary research and how this allows us to understand it, animal studies, this is one way that you're kind of looking at understanding Parkinson's. So as I mentioned, it's very hard to figure out what's going on in the brain because everybody that has a brain is living and they're a person. And so it's hard to be like, oh, let's experiment on you. Let's use you as our little guinea pig. So especially in the past, now it is I guess it's a lot more controlled. But animal studies were a big thing that were used. So in animals, typically like rats and things like that, inducing Parkinson's in them and then understanding how certain medications might work, understanding how Parkinson's is affecting the brain, and then assuming that that's how it happens in a human as well. Neuroimaging techniques. These are a really big one, obviously very, very, very helpful because we're looking at imaging, the brain in which the, disease or disorder is actually happening. So, things like MRI, a PET scan as well, even like CT scans, other stuff like that, is really helpful in determining what's going on in an individual's brain when they're alive and functioning. So if you're looking at, Parkinson's, you can look at what's going on in this person who doesn't have Parkinson's versus what's going on in this person who does have Parkinson's, and noting, okay, this part of the brain has shrunk. These neurons are hyperactive. These neurons are hypoactive, stuff like that, and determining what's kind of going on there. Okay, and I think this is the last dot point. So CTE. So again, this is a new dot point for this study design, but looking at chronic traumatic encephalopathy, again, as an example of emerging research, this idea of contemporary, recent, new into progressive and fatal brain disease. So CTE is basically, again, it's a pretty new thing, hence the emerging research, or like the knowledge of it is fairly new. And you see it a lot with, I remember watching a documentary about this when I was in year 10, when I was doing 1-2 psych. And it's about like, NFL players. You probably would be aware, or, if you've heard of CTE, you probably hear it in that context. So NFL players or other kind of contact sports, perhaps like rugby, things like that. A lot of these retired players are developing this disease, this brain disease, which is CTE. So encephalopathy is basically just this idea of, kind of impaired neurological functioning. And so chronic is over a long time, and traumatic. So this kind of traumatic source of injury. So the trauma is coming from concussions. So those repeated hits, in a contact sport, that's that trauma. And chronic means over and over and over and over again. So if you've got one really bad concussion that happens and you develop, a brain disorder or encephalopathy, it's not CTE because that's come from one really awful kind of event. Whereas chronic, it's happened over a long period of time. So this chronic trauma has resulted in this neurological decline, basically. So in terms of your symptoms, you basically result in this dementia. So again, you can kind of associate things like Alzheimer's or, dementia. You're seeing a lot of memory loss, personality changes, mental health changes, cognitive changes as well that you kind of associate with dementia. And with this idea of CTE, they were seeing this in obviously retired players, but who are of a fairly young age as well. And ultimately, as it is a fatal brain disease, again, dying at a young age. So then kind of you usually see dementia and Alzheimer's, the onset being, in the elderly. So seeing this in relatively young people as well. In terms of diagnosis, so again, it's an area of emerging research. Not a lot is known about it. And just like Alzheimer's, you can only diagnose it post-mortem. So once you actually look at the physical brain, that's when you can diagnose it. So in people with Alzheimer's, for example, when you diagnose them with Alzheimer's, you're not 100% sure they have Alzheimer's. You're thinking, based on the history, based on this imaging, based on what they're telling me, based on perhaps how they respond to medication, I think this is Alzheimer's, but you can only definitively diagnose it post-mortem. So again, that's kind of the idea here. So based on their history, they played contact sports for a long time, they got concussed 1 billion times, they're showing all these signs of CTE, of dementia, then, it's probably CTE. Again, you can use imaging as sort of a backup, but it might not be the best technique to diagnose it. In terms of treatments, again, really, really hard. It's in an area of emerging research, so not a lot is known about it, therefore not a lot can be done to treat it. So a lot of it is like supportive or palliative, so kind of aimed at decreasing symptoms, but not at the actual onset of the disease. So it's not curative. It's more so, helping with the anxiety or the memory loss and stuff like that. Okay, hopefully that is all making sense. Again, feel free to ask questions if you have any. We'll look at some more practice questions before we go into scientific skills. Okay, so the term adaptive plasticity refers to changes in the brain in size, a newborn baby, response to hormones, or response to learning and experience. So based on the things we've just talked about, it's not size. We know plasticity is more so the kind of actual connection. So we're not thinking changes in the brain in size. A newborn baby, again, we're talking about how adaptive plasticity, not developmental plasticity, which is probably more what you'd see in a newborn baby, but adaptive is, again, if you've got brain damage, kind of overcoming that and changing roles, certain pathways in the brain, or as you learn things, as you experience things, changing, again, neural pathways, you're rerouting, you're sprouting. And then response to hormones, again, not really the best option there. D is the answer that we're looking at. Okay, imaging technologies have been helpful to researchers in the identification of localized changes of the brain as a result of learning specific tasks. This is because researchers are able to observe changes to the structure of the brain, observe a live brain during the learning process, perform surgery to the brain as the person is learning, compare and observe changes to the brain before, during, and after learning. So again, we're thinking about the identification of localized changes of the brain as a result of learning specific tasks. So it's very important for this, again, because the answers are relatively similar, to think about the actual context. So observe changes to the structure of the brain. Potentially, if you look at D, compare and observe changes to the brain before, during, and after learning, very similar. A is just a little bit more vague. So you'd probably be flagging those two. Observe a live brain during the learning process, not like necessarily the best option in terms of thinking about imaging technologies, or not the best way to describe it as well. Perform a surgery to the brain. So imaging is not surgery, you're not opening the brain. So then again, you're kind of at D. So this is a good example of when it's the best answer, not necessarily the right answer, because A is like, you'd almost think about A being the right answer as well. But D is just a little bit more specific and answers it a little bit more clearly. So you're comparing and observing. So if you're identifying localized changes of the brain as a result of these tasks, observing it before, observing it during, and after the learning, that gives you a really good picture of what these changes are, as opposed to observing change to the structure of the brain. I mean, technically, but it's just a little bit more vague. So that's why we're going with D. I do want to flag this though while we're talking about this. Do not necessarily think, and I guess this isn't a good example of that, but if you get a question and the answer is vague, don't think like, okay, it could never be this question. All the time, and I mean like all the time, this is almost like more rare. The vague answer is often the right answer. So you might get 3 answers that are super duper specific, and they'll be talking about processes in really big detail. They'll use all this terminology that's relevant to the topic. And then one will just be very general. And you'll think to yourself, oh, okay, I think this general one, like, technically is right, but it's just so non-specific. It's so vague, so it must not be true. Do not think that way. If the other 3 are wrong, then they're wrong. And often it's because they're too specific. So again, this is a bad example of a question like that, but you may have one, answer where it's a bit vague, but like it's generally right. And then the, B, C, and D, they might be super specific, but there might be one word in there that makes it incorrect. So don't kind of fall into that trap of thinking just because this answer is vague is probably not true. But in this circumstance, it was too vague, so it wasn't true. Okay, so a short answer question here. Stan, who is 3 years old, and James, who is 33, both sustained head injuries and suffered damage to the same area of their brain. As a result of this damage, both have difficulty speaking fluently and moving their right arm freely. So name the lobe and hemisphere of the brain that have most likely been damaged. And then part B, with reference to types of brain plasticity, explain why Stan is more likely to have a faster and more complete recovery than James. So something else with psych in your short answer questions, always mention their names. Always. Assessors and your teachers will literally make you lose a mark because you haven't mentioned their name. And again, which is why I always say psych is so much of application. All application. So to show that you're actually applying it to the scenario, they like to see you use their first names. So bear that in mind when you're answering part B. Okay, so in terms of the answers that we're thinking of, so you can see, name the lobe and hemisphere. So hemisphere, you're thinking about right or left. So it said to you that both have difficulty moving their right arm freely. Remember, we've talked about our hemispheres. They control the, what we call like the contralateral side, so the opposite side of the body. So if your right arm is damaged, your left side of the brain controls your right arm, or the right side of your body. So you know that the hemisphere will be on the left. Then comes naming the lobe. So speaking fluently. So what have we talked about in terms of where speech is? Speaking fluently, we're thinking of the left frontal lobe there. So you can see that those are two aspects of this question, but it's 1 mark. So if you were to get one of them wrong, you'd get 0 marks. So there's no half marks in psych, 3, 4 essentially. And so often teachers will replicate that. So I think when I was in year 11 or doing my 1-2 psych in year 10, we didn't do half marks. You got 0 marks or 1 mark because that's how VCA does it. So with reference to types of brain plasticity, so specifically for this one, I hope you guys were thinking of mentioning adaptive plasticity. You would explain why Stan, who is 3 years old, is more likely to have a faster recovery and also a complete recovery compared to James, who's 33. So you bring in their age and this idea that the younger you are, the more successful the brain is at kind of adapting and forming new circuits and things like that. And how that will happen faster, again, because you're younger, but also complete. So in, let's say that the, right frontal lobe was removed from a 3-year-old and a 33-year-old. In the 3-year-old, it's likely that they will actually be able to kind of function, let's say, like as normal, and there won't be any major deficits noted. Whereas in the 33-year-old, they may be able to regain a decent amount of function, but there will still be part that's completely lost their function. So that's the idea of the complete recovery. So you can see here, name the lobe in the hemisphere. So the left frontal lobe, blah, 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 controlling movement of the right side of the body. So the left frontal lobe, this area, hopefully you're thinking of Broca's area. And again, that's how I kind of think of it, like Broca's area, motor, like actual production, and then auditory cortex, Wernicke's area. So that idea of hearing and understanding. Okay, so 6B, blah, 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 blah. Correct response stated that. So Stan's 3-year-old brain has the benefit of developmental plasticity or access to both developmental and adaptive. James' mature brain will be limited in its recovery. So hopefully, again, this is obviously you're thinking of like a very well-versed student with VCA marking here. I know you guys that we're just talking about this. So hopefully what you guys are thinking about in that time is this second dot point. So James' mature brain will be limited in its recovery to the mechanism of adaptive plasticity. And thinking about this as well, the processes of rerouting, and sprouting in adaptive plasticity are less efficient than the ability to form new circuits. So it's just this idea that when you're 3, you may have these kind of aspects of synaptogenesis in which new synapses are forming. Whereas if you're 33, you don't really have new synapses forming. It's more so, again, the rerouting and the sprouting as well. Okay, So that's it for the actual content in terms of the area of study, areas of study 1 and 2. So hopefully everything's making sense. Again, if you've got any questions, feel free to pop them in the Q&A. But now we're looking at scientific skills. So again, super, super important both this year across both units and next year across both units. You'll have your kind of area of study 3. So you'll have, it might be a test, it might be a poster, you might be doing your experiment. Next year in psych, again, it can vary between schools, but you will most likely be doing perhaps a poster or some kind of logbook or formulating your own experiment. So it's really important to get a good understanding of these terms. So in terms of an actual poster or a scientific report, you'll have these different sections. You need to be confident in what each one involves. So introduction is often like your background, why you're doing the experiment, what previous knowledge there is on this topic. Methods is step 1, step 2, step 3. How am I doing this experiment? Results, what are the measurements, the data. Discussion, based on, in the instruction and the results, how can I tie these together and what do these actually mean? And then the conclusion is basically a little summary of that. So in terms of really, really important things that we're thinking of, hypothesis. So if you're going to conduct experimental research or an investigation, you need to have an assumption or an expectation of what's going to happen. So you need to include these 4 things. So iPod. Again, you'd be pretty confident with these things from, junior science and stuff like that. With psych, something that is a little bit more specific is this idea of population and operationalizing your variables as well. So your independent variable, the thing that you manipulate, the thing that you change, the dependent variable is the thing that you measure. Population is where the sample is drawn from. So unlike, your biology or your chemistry, with psych, when we're doing research, we're doing it with participants who are humans. So that's where the main variation is. Whereas we're not doing it with enzymes, we're not doing it with plants, that sort of thing. So you have a population, you have a sample of participants, and these are drawn from a bigger population. So in your hypothesis, you need to refer to the population. You can imagine, are you doing it in kids? Are you doing it in adults? Are you doing it in people who have an IQ of, 200? Are you doing it in people that have Alzheimer's, dementia? Are you doing it in women that have dementia? Are you doing it in all, there's so many different populations. If you exclude population, it is almost unhelpful because you don't know who you're going to apply this to. You don't know who you're going to generalize the results to. So it's really, really important to outline your population. And it can be really broad. Australians, Victorians, it can be really big, but you just have to outline it. Operationalizing, that basically means just being specific with your variables. So your IV and your DV, instead of perhaps if your DV, let me think, will have better memory, will, recall more. It's this idea of how are you measuring it? We'll score higher on a recall test. We'll remember more words on a recall test. Dependent variable will have greater athletic ability. What is that by? We'll be able to run further. We'll be able to run 100 meters in a shorter time. It's just being very specific with your variables. So here's an example. So Australian adults who read at least 1 book per week will score higher on a standard IQ test than Australian adults who don't read books at all. So very specific, as you can see here, clear mention of the population and your variables. A really important thing, I remember my teacher used to always say this to us. Always remember the comparison. It's very easy, and I feel like, again, in your general science and your biology and stuff like that, it's easy to just make the inference of what's going to happen in the experimental group. So Australian adults who read at least 1 book per week will score higher on a standard IQ test. So many students just leave it there. You have to mention your experimental group and your control group. You've got to mention both interventions, basically. So Australian adults, blah, 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 score higher on an IQ test compared to Australian adults who don't read books at all. So you have to include that other one. Otherwise, Australian adults who read at least one book per week will score higher on a standard IQ test than who? Like, you can infer that it's people who read at least less than one book. But technically, it could be score higher on an IQ test than Australian adults who read 10 books, who read 50 books, who read ebooks. You have to be specific. You have to basically cover all of the variables, all of your groups. Okay, these are just some kind of like general things to be aware of. Not using personal pronouns, not being very opinionated, I guess you could say. So, using language such as amazing and things like that, and using psychological jargon as well. It's a formal piece of writing. It's not casual. Okay, super, super, super important slide here, knowing your experimental designs. So your independent groups, again, you know what I'm going to say, as the name suggests, 2 groups, independent, not mixing with each other. One's got one thing, one's got the other. So you're in the control group or you're in the experimental group. So you're receiving the, intervention or you're not. So, you're receiving the drug for Alzheimer's or you're not. You're doing the memory tests, I don't know, under the influence of alcohol or not. It's this idea of one group being the experiment, receiving the actual thing, and one being the baseline or the comparison. So this is the most common one you'll see. So compared to the others, lower cost, lower time. However, a big drawback of it is that there can be individual participant differences. So there are things that will control for that, such as random allocation, random sampling, stuff like that. That helps, but there may still be these participant differences because you've got different people in different groups. It may just be that, more of them have a higher IQ just randomly compared to others, or more of them, I don't know, have a greater experience doing, something than the others. So that's kind of a bit of an issue that can arise. Matched participants controls for that issue. So you don't have, or you minimize a lot participant differences because you basically have your independent groups, but rather than just allocating everybody randomly, you find participants that are similar on a certain characteristic. So let's say you're doing an experiment on memory. So with independent groups, you get your sample and you go, okay, flip a coin, you're in that one, you're in that one, you're in that one, you're in that one. You have no control, like it's randomized. So again, that's helpful. You're not purposely moving people about. But it means that just by chance, perhaps people with really good memory are in one group, people with poor memory are in the other. With matched participants, you get your participants and you give them a memory test, and whoever matches up, these 2 people have the lowest memory, these 2 people have the highest memory, these other people, these other pairs have a very similar memory score on the test. And then, so you've got your pairs and then you allocate 1 to each group. So it's almost that they're the same, really. You kind of see them as one person for the sake of this, hence the name matched participants. So it controls for those individual differences, but as you can imagine, it's very time consuming and costs a bit more. And also if one person drops out, that whole pair is gone. So that's an issue as well. Repeated measures. So basically you've got one group of participants. They do both the experimental group and the control group kind of task. So this obviously is the best in terms of you don't have any participant differences because everybody is doing the same thing. However, you come into this idea of order effect. So it's this idea that the results can be skewed because the participants are repeating the same task. So perhaps they might get bored of it. Their results will be, different than what it would have been if they hadn't done it before. Or they do the task and they get good at it. They've had practice at it. So the second time, they're just naturally better, So even though they've gotten this new drug or intervention, even without it, they would have scored higher because they've had practice at it. So that's where this idea of counterbalancing comes in, which we'll mention. So in terms of actually getting your group of participants, you've got your population. So your population is year 12s, year 12s in Victoria, right? That's a population. So every single year 12 in a Victorian school. You will then sample. So perhaps you get 3 year 12s from each school in Victoria. That's your sample. And then you randomly allocate them to the experimental and the control group. So it's important to understand the difference between sampling and allocation. Sampling is actually picking who is going to participate in my experiment. Allocation is who is going to be in the control group, who's going to be in the experimental group. So you'll have random sampling, which is randomly picking who's going to participate, and random allocation, which is randomly picking who's going to be in what group. Okay, so you guys may be familiar with blinding as well. So again, all of these steps are to prevent anything affecting the DV that isn't the IV. So you guys may be familiar with like confounding variables. Basically, all of these steps are random sampling, random allocation, your independent groups design or your matched participants design, your counterbalancing. You're wanting to avoid anything influencing the results that you don't want to. So if you're testing a drug, you want to figure out how this drug is, improving memory, right? You don't want an individual's age or an individual's IQ or an individual's expectation of what the drug will do to influence their results, practicing, the order effect. You don't want any other variable that is not this drug to cause a change in their memory ability, basically. So single blind and double blind, it basically conceals which group the participant is in so that the participant doesn't, often like unconsciously influence the results. So if you are testing, improving like a headache with Panadol or some other miracle drug, if you tell the person, okay, you are receiving this miracle drug, or if you tell the person you are not receiving this miracle drug, that's going to influence their responses. So, how much has your headache reduced? I know that I was told I'm taking this miracle drug, so I'm sure it's done really well. I feel better. I feel more energetic, all that kind of stuff. Whereas someone who has not been taking anything, who knows that they're not receiving this miracle drug, they're not expecting any improvement. So they're going to say, I don't have any improvement. So that's the point of a single blind, not telling the participants what group they're in. Double blind is not telling the participants and also not telling the researchers or the, assessors, the people who are analyzing it, what groups you are in. Because if you are the experimenter or the assessor and you go, okay, this person is in the drug group, you may unconsciously, kind of ask them questions or hint that you want them to be giving certain replies. Or even when you're interpreting data, you may think like, oh, okay, I think they're in this group, so they should be acting like this, and stuff like that. So that's why double blinds are usually the thing that you want to aim for. Standard deviation. So this is just kind of terminology, basically. You just have to understand that the standard deviation has to do with the mean, and it tells you how broad your scores were. So, let's say we're doing like something affecting memory. The mean, is in the middle. If you've got people who are, really, really low compared to the mean and also really, really high compared to the mean, so what we're kind of looking at here, it's a large standard deviation. So that means there's greater variance between the scores. And that's kind of telling you like you're doing something a little bit wrong. Because if you've got, again, this kind of miracle drug that's increasing people's memory, you've got the mean. If you've got people that are like really, really low on one end and people that are really, really high, then it's kind of like, what's going on to make people so different? Whereas if you've got a low standard deviation or a small spread, that means you've got less variance, which means everybody kind of got similar results, which is what you're wanting. Okay, so generalizing, this is really important in psych research. So you need to be able to, you've got your results, You're saying, okay, this drug is really good at improving everybody's memory, improving Alzheimer's, whatever it is. Can you generalize this to the population? So the question is, does your sample accurately reflect the greater population? And, the fact that this drug has worked in your sample, is it likely to work in the rest of the population? So therefore, to figure this out, you have to determine, is my sample representative or not, basically. So you need to think in terms of the sampling, like, is this random sampling? Is it stratified sampling? Are they actually represented? Have I used a big enough sample size so that I've got, again, a good representative of the population? Is the IV actually affecting the DV? I don't have any confounding variables. And then obviously, have I obeyed like kind of ethic principles? Is this experiment valid, basically? So if that kind of ticks everything, then you can generalize it to the population. This is super important. If there's one thing you remember from the scientific skills thing, let it be this. Screenshot it, do whatever you have to. Know this like the back of your hand. It's on improving stuff. You'll get questions about this. Here is, we've used a repeated measures design. How can we improve it? Counterbalancing. We've used convenient sampling. How can we generalize it? Random sampling. The experimenter knew what groups people were in. They unknowingly influenced them. Double-blind procedure. It's really, really important. Counterbalancing I haven't mentioned. So you have your repeated measures design. Remember, we've talked about, practicing or getting bored. Counterbalancing is when you take half of the group and they do one task and then the other half does the other, and then you swap. So let's say you've got task A and task B, you're controlling your experimental group ultimately. So instead of having all 50 participants do the group A task and then all 50 participants the next day doing your group B, which again could lead to the order effect. So influencing, the results based on performing the thing the same time, like the next day. Counterbalancing is when you have 25 people will do group A and then the group B task. And then the other 25 will do the group B task and then the group A task. And because you've switched the order, it means that this order effect has been cancelled out, basically. So people are doing it in a different order, which means there shouldn't be any influence on the result of kind of doing the tasks twice in a row. Because, some people did it, did this memory test under the influence of caffeine and then they didn't. And then some people didn't do it under the influence of caffeine and then the next day they did it. So that means that it's kind of balanced out. It's not this, everyone did it like this and then everyone did it like this. So hopefully that makes sense. Okay, ethics, really, really important. Privacy, basically. Confidentiality, again, kind of privacy here. So not naming people, not making them identifiable. Voluntary participation, not coercing someone to participate, not punishing them or deterring them from not participating as well. Withdrawal rights, again, being free to withdraw, not punishing them for withdrawing. Informed consent, so they have understood everything that's going on in the experiment, they've understood the risks, they know the purpose of it, and they provide their written consent. If you are under the age of 18, or if you have like a mental health disorder, for example, you will get a parent or a guardian to sign this consent form. At the same time, and again, you go over this in year 12 as well, in the case of mental health disorders, you would not explain everything to the parent or the guardian and leave the participant in the dark. So let's say, for example, it's someone with perhaps like schizophrenia or something like that. You'd explain it to them to the best of their understanding and then, do the same with the parent or the guardian and get their consent. So you want the participant to be fully, or, to the best of their ability, aware of what's going on. But because legally you wouldn't deem them as having capacity, that's why you get the consent from the parent or the guardian. But it's not that you get the consent from the parent or the guardian and you don't tell the participant anything that's going on, because that's not ethical. That's not informed consent. Okay, so deception, basically when you lie about what's going on. So you can kind of think of this as, withholding information, and obviously this can be important in certain settings. But it has to obviously be, it can't cause, again, physical harm, it can't cause trauma. And you have to tell the participant about it after the experiment has been concluded. So deception can obviously be a little bit distressing and things like that. So you have to get explicit approval from the ethics committee to use deception in your study. And then debriefing. So that idea of revealing deception. But then even in experiments that haven't involved deception, debriefing is just kind of going over the results and letting everybody know what happened in the research, what the future, findings might be and stuff like that. Okay, so that is it for the most part. We'll just go over our last couple of questions before we end off. So a researcher wants to conduct an experiment with primary school students. Which of the following describes the most appropriate ethical approach for the researcher to take? So with these, the way I like to do it is just look at the first column, see what you can eliminate, and progress as you go down. So written consent from teacher and student. So a researcher wants to conduct an experiment with primary school students. The teacher is not the legal guardian, so that wouldn't be the right thing to do. Verbal consent, no, it has to be written. Verbal consent, no, it has to be written. So written consent from parent, guardian, and student. So already, based on this first column, C is kind of looking like the only right one here. So you can, if you're running really tight on time, you'd probably circle it and move on. But obviously, we don't want to do that. We want to make sure that it is correct. So debriefing procedure available. Disclosure of deception before student takes part. That doesn't make sense. There's no point to deception if you're going to tell them about it before the experiment has occurred. Counselling offered at conclusion, again, only if necessary. If this experiment isn't, causing any kind of major psychological trauma or anything like that, probably not necessary. Whereas information about findings provided at the end of the experiment, pretty valid there. Again, wouldn't make sense to, outlining counselling options before experiment, again, valid, but only in the setting that it's necessary. So again, this one is looking like the best option. And then withdrawal rights, student can withdraw or parent guardian can withdraw student anytime. Sounds about right. Teacher can withdraw. Again, the teacher is not the legal guardian. If the teacher said something, you'd obviously probably flag it. But yeah, the student can withdraw or the parent guardian can withdraw them as well. But see how you can understand, even though you get the legal consent, the written consent, also from the parent and guardian and from the student as well, you don't need the parent or guardian to say that you want to withdraw them. If it's just the student that says it, that's enough to withdraw them as well. Because again, you can't keep them against their will. That's the opposite of withdrawal rights. Okay, so Lucinda read that a dog's breed influences, blah, blah, blah. I'm just going to skip this. But you can see one group of beagles and poodles to do this. In the second part of the experiment, Lucinda compared how many sessions of training were needed to get a different group of beagles. So a different group, we're thinking of independent groups design there because it's two different groups of participants. If Lucinda used the same beagles and poodles for both parts of the experiment, so i.e. if she used a repeated measures design, would she need to counterbalance the experiment? The answer should already be yes. So you can rule out A and C because we've got a repeated measures design, the order effect would be coming into it. So yes, because the order of the treats might affect the results, or yes, because the training order might affect the results. I will let you know as well, this question was answered poorly by students, so don't worry about it, if you're a little bit confused or you get it wrong, because it was answered poorly by year 12s, at the end of the year. But you can see here, you have to think about the independent variable, because remember counterbalancing, it's to eliminate the order effect, which is a confounding variable. So we're wanting to figure out what the IV is. So beagles and poodles to sit in a designated spot for 30 seconds using a dog biscuit as a reward versus getting them to sit in a designated spot for 30 seconds using a dog toy as a reward. So the consequence or the reward is the difference. So that's why we're thinking more so the order of the treats versus the training order, because the treats is what's actually changing. The training order isn't necessarily changing. You know, they're sitting in the spot for 30 seconds, they're sitting in the spot for 30 seconds. It's this idea of they're sitting in the spot for 30 seconds and then they get a biscuit, or they're sitting in the spot for 30 seconds and they get a dog toy. So if you got everybody to do a dog biscuit and then everybody to do a dog toy, with the dog toy one, they might get better results because they've had practice at it. So that's why it's the order of the treats. Okay, we've got a couple minutes left. So thinking about your kind of standard definitions of your skills here. At a university, 40 students participated in a study examining the effects of loud music on typing accuracy. Students were given a typing test to complete, with 20 students listening to loud music and 20 students without music. So what is the IV? So the thing that is manipulated. So you're just looking at what's different. The effects of loud music on typing accuracy. So you know that you're already testing loud music. So the thing that's changed is whether they listen to loud music or no music. The dependent variable is what's measured. So effects of loud music on typing accuracy. So the result of the typing test. Identify 2 uncontrolled variables in relation to the participants. So you've got 40 first-year psych students. You're subjecting them to a typing test, and you are getting them to listen to music or no music. So you can think about uncontrolled variables. So this idea of, are some, already good at typing? Are they poor at typing? What do they usually listen to when they type? Even things like, how old are they, or certain characteristics, like intuitive characteristics, about these students as well. So you can see here the music, the typing accuracy, what they ate or drank. Again, this can be like literally anything, what they, if they slept the night before, anything that can affect typing accuracy. So again, the prior typing experience, hearing impairment or ability, because obviously you're listening to music. So yeah, heaps of answers you can write there. Get very, very confident with stuff like this. Identifying the IV, identifying the DV, coming up with a list of uncontrolled or controlled variables, and also thinking about what are some improvements that I can think about making to this experiment. Okay, so coming to our last slide here, basically perfectly on time. So as I've kind of mentioned, psych is a very big subject. Honestly, with this study design, I think they've taken out a decent amount of stuff. So they are kind of cutting back a little bit, but it's still pretty big, and same with 3-4 as well. That's why I really emphasize use the study design to guide you. I used to do like chapter summaries of the textbook, but with psych textbooks, they can include so much irrelevant information, so much writing, so many case studies that don't have any relevance to you. And especially if you're just passively writing notes, it's a waste of time. So what I would suggest to do is, again, like I mentioned, put the study design dot point at the top, write everything, and constantly refer to that as your kind of guide as to what you're writing, so that you know that you're always keeping things on track. Create your own resources. So creating those, your chapter summaries, writing your own questions, creating flashcards, all the kind of things, drawing your own diagrams, especially for certain processes. All of that stuff is really, really helpful. And it makes, because it's learning actively, you're putting information in much kind of stronger than if you're just reading a textbook. So I've mentioned that kind of in the third textbook in terms of figuring out what is relevant and what's not. Practice questions. I cannot emphasize enough. Please, please, please do your practice questions, just like we've littered some throughout the slides here. Because psych is all application, practice questions are really important. Once you know the content and you're pretty much on top of it, seeing, what are some really common question types, what are some really common scenarios, and in terms of what's the best way to answer these questions? What do I need to put in a 2-mark question? What do I need to put in an explain versus a state or a describe question? Practice questions are just extremely, extremely helpful. Again, like effort as well. You kind of get out what you put in. Psych can be seen as both like an easy and a hard subject at the same time. I think people see it as hard because there is a lot of content, but easy because the content is often pretty like okay to grasp. It's a lot of stuff that you already have a bit of awareness of. So if you just put in the time and the effort, again, do your practice questions, take your time to understand it, you can get a lot of like bang for your buck. So you put effort into it, it's not difficult to do well, if that makes sense. And then lastly, yeah, enjoy. I know it sounds like dumb and cheesy, but especially for me, like 3-4 as well. 1-2, again, the study design has flipped around a bit, but the stuff in 1-2, again, it's things that you're aware of. It's things about yourself. That's what I always thought when I studied 1-2 and 3-4 psych. You're learning a lot of stuff about yourself. It's about your brain, it's about your development, it's about your perception, it's about your mental health. So that's why I found it interesting, because it's stuff that directly applies to you. So, if you see it as a little bit boring, or you're not really liking it, I don't know, try to take it with that approach, and also, yeah, kind of think about and understand how it's relevant to you. Like next year you talk about stuff like sleep and again, like learning, memory. So there's a lot of stuff that you might find relatable, or stuff that you can almost apply to your own life. And again, that's almost a way to study as well. When I used to do stuff on learning and memory or on stress, I always wrote my examples that related to me. So like with your memory, I used to think of things in the example of when I'm learning psych information, when I'm learning stuff about, maths, when I'm learning stuff about English, what are these processes going on in my brain? And it helped relate it to myself. And then so I learned it a little bit better. So same things, perhaps like the brain, synaptic plasticity, perception as well, thinking about those sort of things. Hopefully that can help it sink in your brain a little bit more. But yeah, hopefully that makes sense. Again, pop any kind of last minute things in the Q&A if you have. If you've got any other further questions, feel free to email me as well. It's just lourdes@tutesmart.com. Yeah, but hopefully it has been pretty helpful. I wish you guys the best luck with psych. Enjoy the term, enjoy the rest of the year. And if you go on to psych 3-4 as well, good luck with everything. Yeah, I'm sure you guys will do really well. There's no need to stress about it at all. But again, yeah, just put in a bit of effort and you'll be able to tackle it really easily.